not using software is almost impossible today, since software is a nearly vital tool for healthcare, banking, shopping, utilities billing, you name it. It's like involved in some way, shape, or form. Uh, I've listed Moore's law here to show how important computing is. I mean, Moore's law essentially states that the transistor capacity of an integrated circuit will double every 2 years, and this is a widely accepted, historically based sentiment, and it's used to predict how computers should be more efficiently built in the future. Not only not only is software extremely important in our daily life, but it's only going to get more important as time goes on, maybe even exponentially so. Because of this, it's very important to keep bigger implications in mind when we try to implement software into more daily activities. I mean, sometimes software fails. It may be more manageable when this occurs in the form of a small bug in Microsoft Word or something, but it can also lead to more harmful results, like the various stories of self-driving cars malfunctioning. And on top of this, technology has been shown to affect the environment. I mean, this makes sense. Software runs on hardware uses electricity, and the most common forms of electricity production use non-renewable like resources and pollutants. Because of these and many more implications, it's very important to analyze what the software development process might look like in the future and how we can mitigate those. So in the future, in 5 years, I expect there to be a merger between a few philosophies that are currently really dominant. Uh, I expect this new merger to be the most used philosophy for software development. Let me explain a bit. Right now, there are many philosophies around software development. We have waterfall, ad hoc, extreme programming, etc. I want to focus though on agile, a consumer-centered philosophy, and user-centered design, which I'll call UCD, which is an end-user-centered philosophy. Agile and UCD are really similar. I mean, they make modular teams dedicated to specific methods and stuff like that. The main difference is the priority, like of the result and who makes up the teams. Agile seeks to create result mostly for the customer, using requirements elicitation and other methods to ensure that the uh, things the customer wants are put into the program. UCD, on the other hand, creates the application with a general end user in mind, mostly focusing on things like UI and UX, and with teams consisting mostly of like designers. There already have been studies on merging these two philosophies together, and there has been some success, which is why I believe this to be the dominant form of development in 5 years, especially considering the more growing importance of UX in software today with web applications and the like. I also see a continuation of the current wave of AI that we've been writing more recently. I mean, albeit in a pretty limited form. AI suffers from a couple problems. One of the most damaging are what people call hallucinations, when AI responds to a question with incorrect answers. Uh, for people using AI expecting answers, this could instead greatly mislead them, something that could cause time or efficiency loss in a software project. So I only see AI as being like mostly used as an inspiration. In this sense, though, AI can help with bug fixing. It can help with searching through the internet to find the cause or solution for a specific error code. But it would probably be best to keep a disclaimer warning in case of hallucinations, like warning of them, and to only implement this kind of thing in non-vital software to mitigate risk. On top of this, people could use AI as inspiration for code solutions. I mean, there already has been an influx of people turning to ChatGPT for help on coding problems, and I see this trend only growing in the future. Code will still be taken from AI with caution, though, to avoid catastrophic or confusing bugs later on. Moving on from AI, we have environmental impact. It's important to create efficient code because, as I mentioned in the slide prior, programming eventually causes pollution. I expect more consideration for how efficient a software's code is, specifically with the goal to lessen the results usage of hardware resources. Another way software could be more energy efficient is through blockchain. I mean, depending on how you use it, blockchain has been shown to improve transparency, traceability, and energy efficiency. It's important, though, to use blockchain correctly for this end goal. since blockchain-dependent projects like Bitcoin have actually been shown to use greater like amounts of pollution, or produce greater amounts of pollution than many countries. It is actually wild looking into that. Moving on to 10 years, uh, I don't really expect I don't expect much trajectory to change compared to 5 years. I still expect the merger of agile and user-centered design to continue, likely to be more pronounced due to increased importance we put on user design today. The major difference I see are in the strides in AI. I expect by this point, AI may reach a point where hallucinations happen much less than they did previously. In this case, AI can take an even more important role in the development process, namely with bug fixing, possibly even using like historical data at this point, and maybe even code generation. It might be best to implement a modular team dedicated to finding ways to implement AI into the project in a way that would improve productivity and increase the quality of the result. Uh, but that's dependent on the software. AI could also be used for inspiration and requirements elicitation as well, since it may provide interpretations of what the customer wants that maybe the like project manager, maybe we initially missed. By 10 years, the changes we witnessed from our efforts to curb pollution would be more visible, but climate change itself won't be stopped. Classifying systemic effects of a software might become like a staple consideration in the design process, specifically emphasizing energy efficiency, because the more hardware resources are used by a software, the more pollution it would create. So it's difficult to see where software development will be in 50 years. I mean, assuming current models posited by various like ground research, by this point, we're already likely to experience catastrophic events ranging from intense flooding to some species extinction. It's hard to determine if the previous attempts at mitigating pollution will be successful enough to prevent any of this. So, assuming it is, I predict further emphasis on code efficiency, possibly producing guidelines to limit how much a given software can interact with the hardware, depending on how uh, big the problem of, like, what is it? The problem of, I'm trying to think of the word, climate change is by this point. There we go. I don't know why that took so long. Aside from this, I expect to see great strides in prospective technology, specifically quantum computing. Quantum computing is known to provide much higher computational speeds than normal computers, much higher, due to quantum superpositions resulting in parallel computations. This parallel processing has really heavy implications to AI and would likely make responses much faster, and those responses would probably be much higher in average quality. There may even be from this like wave an entirely new paradigm shift, which could involve software development specifically for quantum computing. But that's hard to say right now since the topic is really recently being delved into. It is something to consider, though, that may change the development landscape because there is more research going into software for quantum computing, and it is very interesting to read through. From this, AI integration could take even larger roles in a project, and bug fixing could be even more efficient with AI providing more detailed and project-specific solutions to error codes. AI could even analyze like whole code bases in a way project managers can't really, to look for inefficient interactions or to make bug preventions based on the history of the code base, the history of bugs in that code base. There's also a new opportunity to include AI on the user side. There's already been testing with this. Like for instance, you've probably seen some tailored advising, or sorry, some tailored advertising things. But AI, like this AI could improve the user experience just by conforming to how the user wishes to use the software, how they do it most. And this could make the end user experience much more customizable. It could also be tailored by the developers to fit the software's needs and so on. So those are my predictions, but there are some limitations to them that are important to consider. First, the online realm is changing faster than ever before and likely will keep doing so. It'll be hard to make some predictions because of this volatility, so it just depends on time. Similarly, it's hard to tell if problems surrounding AI hallucinations will ever be solved to the extent I think it might be. Through the essay, I rely on kind of time to do the work, but the work may be a lot harder than I predicted. And hell, maybe by the 50-year mark, even still, there will be major problems like there are today. Teams are working right now to improve AI around this very topic. In regards to the environment, maybe other sectors have drastic impacts on climate change that programming specifically might not be able to address. Like, even if software becomes much more efficient in the future, there are many other sectors we need to hope will do the same for the best case scenario in 50 years, maybe even 10 years. My most important predictions from this presentation include the merger between UCD and Agile becoming the dominant philosophy for software development, AI integration becoming more reliable and inspirational for developers, and quantum mechanics taking center stage to provide intense computational power.